So in this video we get to the interesting part, which is writing the server side of the protocol with DKVf. To implement the server side of the protocol, the first thing that I need to do is obtaining the code of the DKVf from the repository. So I have already done that, and so I have a copy of the repository in my working directory. So what I need is the DKVf core. So I use the content of the source directory in this and copy to the source directory of my project. So you can alternatively use jar file, but I'm using the actual code in this video. So, and because it also relies on Oracle Berkeley DB, so I add Oracle Berkeley DB jar file. You can obtain it from the Oracle website. Okay. So now I create a package. You can use any package name. I use example eventual consistency. And inside this package, I create a class called eventual consistency. Right. So to implement the server side of a protocol in DKVf, we need to write a class that extends the DKVf server. Okay. So we need to call the superclass comparator. We also need to implement any class that extends the DKVf server has to override two functions. One of them is the handle client message and the other is the handle server message. So the handle client message is called by the framework, is invoked by the framework whenever the server receives a new client message. All right, and the handle server message is invoked by the framework whenever the server receives a new server message. So I need to basically implement my protocol using these two functions. So let us start with the handle client message. So in this function, we want to first see what kind of request we have received from the client. Okay. So the function received an object from client message agent. Okay. So this class has a function called get client message, and this is the protocol buffer object. So using has get message, I can check if the message has the get message. Okay. If it has the get message, what I'm gonna do is I called handle get message, and I pass this. I need to implement this. And otherwise, if my message has put message, I called handle put message. Okay. So what I need is to implement these two functions. Okay. So in this function, the handle get message, I will service get messages, and in the handle put message, I service put messages. All right. So let's first write the handle get message function. So first I retrieve my get message from my client message agent object. So again, I use get client message and get message. Okay. So the framework provides a function to read keys that we have already written, or write new keys. Okay, so this function is called the read function, and so it receives a list of record as the result parameter and fill it with the found key. So I create a list of record that I will use as my parameter to call the read function. So I now call the read function of the framework, and so the read function receives the key that we want to read. So the key is provided with our get message. So I say get key. Okay, it also receives a predicate that decides which keys it should return. So if I use return true, then it always return the first key according to the order that I have defined by my comparator. Okay, and then I provide the result object, list object, to be filled by the read function. So I create a client reply object. I set it to null. Now I check the result of my storage operation. So if ss equals to storage status success, if it's equal to that, so I retrieve my record, I call it rec. So the first element of this list will be the key, the record that I was looking for. So if it's successful, it means that the read function has found the key. Okay, so what I need to do here is creating a reply message, client reply, and send this reply to the client. So I say cr equals to client reply new builder, set a status to true, set get so I want to create a get reply. So inside this I say get reply new builder set value to record.get value, and then finally I build. Okay, this is the response that I want to send to the client. So if the operation is not successful, then my reply will be client reply set status to false and build. Okay, so the good thing about the client message agent is that I can easily send a response to the client using the send reply function. So I call send reply and I provide my the CR here. Okay, so I hope it's clear for you that what we did in this function. So we first obtain the get message, okay, and then we call the read function. So the read function asks for the key, so we obtain the key from the get message that the client has sent us, and we provided a predicate true, so, which always return true. So it says that okay, return the first key, and then we fill this function fill the result for us. So if the operation is successful, the first element is the record that we were looking for. So in this line I create a reply for the client. So I use the client reply object that is created by protocol buffer for me. I call new builder. I set a status to true. So remember this the status and the value here or what we define in our protocol buffer, I mean .port2 file. And if the storage is not successful, I create a client reply with a status false. And then using send reply method of the CMA, I easily return the value to the client. So using DKVf, I don't need to worry about anything. So the framework will call this function for me and provide an easy way to respond to the client. Okay, now let's go ahead and implement the put message. So let me remove this comment from here and implement the put message. So in the put message, we receive a key and value from the client, and we need to write a new record to our data store for the key and the given value. Okay, so I use a record object, I mean a record. I can actually use a record builder. Let me do this, and I create a record builder. So in my builder, I set value to cma.get client message, get put message, get value. Okay, and also I set update time to the system system current millis, okay, which basically the current time. Also I can set the source replica. So for source replica, I will use PID. I will define it later. No, actually I will use DC ID or data center or replica ID. So I will define it later. And now I can create the record rec by calling the build function of the builder. Okay, so this is the record that I have created. So now I need to store it in my storage. So I called builder, I call insert. So for the insert function needs a key and a record. So for the key, I can call get client message, get put message, get key, and the value is the record that I just created. Okay, so now I need to check if the storage was successful or not. So if the storage is a storage success, I do something, otherwise I do something. So if it's successful, I create a reply message that basically tells the client that the operation was successful. Okay, so I call the client reply, I call set status to true, okay, and so I create a set put reply. And so for put reply, I create a put reply message by calling new builder, and I just set the update time to the time of the record. Okay, and then I call build. Now the reply is ready. So if sorry, I need to define client reply here. So if the operation is not successful, I just set the status to the false, and of course build. And now I need to call the cma.send reply cr. Okay, so that's it. This is the only thing that actually in the put message, once we are done. I mean, from this line to this line, we write the key value to our storage here, and here we send the response to the client. So, but when there is an update in our replica, we need to replicate or send replicate message to other replica to let them know about the new update. So for this purpose, I mean, after sending the response to the client, I call a send replicate message, and so basically I provide the key and the value. Okay, and so I need to define this function. So in this function, I want to implement the replication strategy. I mean, the replication code that basically this node sends replicate to other messages. So I need to define this variable, which is the ID of my server. I mean, the replica ID of the server. So I define it here, which is an int. Okay, and then I will go and define this function. All right, so now we want to write our send replicate message function. Okay, I can ask Eclipse to create the. Okay, so in this function we want to send a replicate message to other replica. So remember that the replicate message format is defined by our proto file that we saw in the first video. Okay, so but before I start working on the send replicate message, I define a member. Actually, I define two members for this, which is a PID, and another is num of data centers, or num of replica. Actually, is num of replicas. So let me explain a little bit about the structure here. So I'm creating a eventually consistent distributed data store for a partition and replicated system. So which means that we have several replica. Each of them has a full copy of the data, and inside each replica we have a set of partitions that any of them has only a partition of the data, and partition are disjoint. And so this is partition ID, okay, and this is replica ID. So each when there is an update in a server, which is a partition inside a replica, this partition needs to contact with the other partitions in other replica to inform them about the update. Okay, so here the first thing that I need to do is create a replicate message. Okay, so the replicate message is a type of server message that we define in our .proto file. So I create a server message by new builder. I set replicate message. Okay, so here I create a replicate message, new builder, and for the replicate message I need to specify the key, right? So I want to say what key I am replicating, and set record, which is rec. Then I call build, and that's it. So this is the server message that I want to send. So notice that how convenient is creating message to serialize over the network using a protocol buffer. Now I create a for loop that starts from 0, and it will repeat for the number of data centers. Okay, So if I equals to current data center, I just continue. Okay. Otherwise, I send the message, that I created to the corresponding partition in replica I. Okay. So the way that you let me put it this way. So to send a message, we need to use the send to server via channel function. This is provided by the framework. Okay. And this function is part of the DKVf server. So this function receive So this function receive an ID and a message. Okay, so the ID you define the ID in the config file. So we will get to that later. But I'm going to define IDs in this way. That IDs are, the first thing is the replica ID, okay, and underline, and the partition ID. So I want to define my config file in this way. So thus my replica ID, I mean the replica ID of the target partition is the I in the for loop, and the partition ID is the same PID as I have for this server. So that's it. So using this, I send a replicate message to the server. So I create a server message here, and then for all other replicas except the current replica, I send the server message containing the new record to that replica. Okay, so now let's write the server message function. So the server message only receive, the only server message that we have in this protocol is the replicate message. So what I'm gonna do is obtain the receive record from my replicate message. Get replicate message, get record, and simply insert this record into my local storage. Get key and the new record. Okay, so sorry, it should be insert. So when I receive a message from another server, it should be certainly the replicate message, because this is the only server message in my protocol. So I retrieve the record of the replicate message that we sent here, right? This is the server message, so it has a record. So I retrieve the record here and then insert this to my local storage using the same insert function that we use for put operation here. All right, so we are done with processing the client message and server message. The only part that is remaining is the constructor. Okay, so the constructor receives an object from the config reader. So the config reader basically reads the config.xst that is published in the repository. And so I plan to have a separate video for the config, but basically you can set many parameters for your for the framework. If you want to have a specific parameter to your protocol, not to the framework that which you probably always have, you can access them by get protocol properties function. Okay, so basically we create a hash map of a string and a list of a string called protocol properties. So using this using get protocol properties, we access all of the properties that are set for the protocol, right? So I want to basically initialize these three member from the config file. Okay, so I say num of data center will be protocol properties get num of data centers. So this is the name that this is I mean, you decide what name you want to have in your config file. Okay, and then it return a list of a string. I use only the first element. So because this is an int, I need to convert it to an integer. Okay. So the same thing for PID and DCID. I use P underline ID and DC underline ID. Okay, so here we only, so because any server instance has different value for PID and DCID, right? And the number of data center I need to specify for the server. So using num underline num data centers in my config file, I plan to define the number of data center, and using P underline ID I plan to define the number of the partition ID, and DC ID is used for the data center ID. So all right, that's it. I mean, this is the whole thing that we need to write to create an eventually consistent data store, and this is the server part. So next we will focus on the client part in the next video.